Logistic models again. We looked at the logistic model numerically back in the beginning, and we looked at the equation, and then also we looked at it numerically. Now we're going to look more closely at the connection between an exponential model and a logistic model. Early on in the spread of a virus, you could model it with an exponential model. That would be pretty close. You can figure out what the growth rate is. In this case, I of t is equal to 12 e to the 0.1324 t. This would represent roughly a 13% increase per time period using a continuously compounded model. It would be a little bit more than 13% actually. So if time is in days, you'd have a little more than a 13% increase per day in virus cases in this case. We saw before, if this initial number of infections, very small relative to this, this exponential rate can be used to estimate the logistic rate. So this is a very simple exercise. In your packet, this is problem number 1. I'm just going to go through it and explain it, and then you can complete the chart for your homework portion. The exponential rate is just simply this number right here, 0.1324. Estimated logistic rate, we're just going to drop one significant figure and use 0.132. How many significant figures this estimates this all depends on the size of the initial population relative to that. Coming up with an exact relationship, we're not going to quite worry about that right now. Suffice it to say 12 is very small relative to 5,000, so you'd probably be safe with 3 significant figures. The initial number of infections is simply this number right here. You can extract that from the exponential model. That's something you might know, just part of the data of our experiment. And then we're going to use that to plug into this. I of t is equal to k. That's given 5,000. 1 plus 5,000 minus 12 over 12 e to the negative 0.132 t. Okay, and you can boil this number down. You can do that on a calculator quite easily. Gotta wait for my solar power here. 5,000 minus 12. And I get 415.6 repeating. So we can adjust this to 5,000 over 1 plus 415.667 e to the negative 0.132 t. And there's our logistic model. This is a bit of a guess. In the early stages of a pandemic, we have no idea how many people that are susceptible. One thing you could do is, if you have quite a bit of data over a month's time, you could figure out what K value fits the data. And that may give you some estimate as what percentage of the population is susceptible. And that would be a guess. The problem is there's a lot of other variables going on here, social distancing and everything. So it's not that easy to get at this. But that's certainly one plan of attack. Try different parameters for K and see what model seems to fit your data. You might at least get a rough idea of whether or not the whole population is susceptible or some fraction of it. At least that would be a good first guess. So the size of this relative to that, we'll have another video explaining that. We'll come out with shortly, just a short video on that separately. So that's all for this.